Good morning, students. Welcome to the class. We were discussing carbon 13 NMR spectroscopy. We have just seen how to calculate the chemical shift values for alkenes. Now we will see how to calculate the chemical shift values for aromatic compounds. This is considered as alpha. That means we are trying to calculate the delta for this. It is ortho substitution, it is meta substitution, and it is para substitution. Now for an aromatic system, the base value is 128.5. Base value is 128.5. Imagine that we are trying to calculate the delta value for the substituent for this carbon. So when we are looking at this carbon, we will take the base value, and whatever the substituent here, it is considered as alpha. Then this position is ortho, this position is meta, this position is para. For example, alpha, ortho, meta, para. So we will take the base value, and these are all additions or subtractions. Right. When we have a methyl group at this position, we will take 188.5, 128.5, and we will add 9.3 to this. 9.3 to this. For example, if this methyl group is at ortho position, if it is at ortho position, instead of 9.3, we will add 0.7. We will add 0.7. For example, if this methyl group is at meta position, we will subtract 0.1. We will subtract 0.1 from the base value. Or if the methyl group is at para position, we will subtract minus 2.9. We will subtract minus 2.9 from the base value. So if it is at this position, we will add 9.3. If the methyl is at ortho position, we will add 0.7. If the methyl group is at meta position, we will subtract 0.1. If the methyl is at para position, we will subtract 2.9. Similarly, when we have ethyl group, we will add 11.7 if we are calculating the delta value for the aromatic carbon. We will subtract 0.5 if it is at ortho position. We will add 0 if it is a meta position. We will subtract 2.6 if it is at para position. Similarly, we will go for isopropyl group. Isopropyl group, we will add 20.1, minus 2, minus 0.3, and minus 2.5. Now look at the alkene, a double bond. If it is vinyl, we will add 9.1, minus 2.4, 0.2, and minus 0.5. If it is a triple bond, it is minus 6.2, 3.6, minus 0.4, and minus 0.3. If it is a phenyl group, then it is 8.1, minus 1.1, minus 0.5, minus 1.1. Here the shortcut is that think that it only influences when they are at alpha position. These substituents will only influence when they are at alpha position. Why? Because the values, either additions or subtractions at ortho or meta or para, they are negligible. Mostly they are between 0 to 2 or 0 to 3. 0 to 3 is not a matter. So just for our exam purpose, we can neglect them, ortho, meta, para. Okay, you just remember only these values, and among these values also this triple bond and isopropyl, they are exceptions, but all other just go for 10, 9, 11, 9, 8. So just go for 10, it's not a problem. Okay, just add 10. Isopropyl we need to add 20. For triple bond we need to subtract 6.2. I'll write it again. We need to subtract 6.2. So these two are the only exceptions. For all other we will add 10. For isopropyl we will add 20. For triple bond we will subtract 6.2. Now we will look at the carbonyl substituents. Aldehyde, methyl ketone, phenyl ketone, carboxylic acid, ester, and then nitrile. We will look at these examples, these substituents. In the previous case, we have just ignored all other substituents when they are at ortho meta para. Now this example is we need to consider alpha value as well as para value. We can ignore ortho and meta. When we have aldehyde, we need to add 8.2 to the base value when it is at alpha position. We need to add 1.2 when it is at ortho position. We need to add 0.6 to base value when it is at meta position. We need to add 5.8 to base value when it is at para position. Similarly, for methyl ketone, we need to add 8.9 when it is at alpha position. We need to subtract 0.1 when it is at ortho position. Similarly, for meta also, and we need to add 4.4 if it is at para position. For phenyl ketone, we need to add 9.1 if it is at alpha position, 1.5, minus 0.2, and 3.8. For carboxylic acid, it is 2.1, 1.6, minus 0.1, 5.2. For ester, it is 2, 1.2, minus 0.1, 4.3. For cyanide, it is minus 16, 3.6, 0.6, 4.3. Now we will look at the shortcut. Yeah, in this carbonyl systems, we need to remember the para also. But how much? It is either 4, 4 to 6. So 4.4, 3.8, 4.3, 4.3. All these values are 4. Or at the maximum for aldehyde, we have 6. Okay. So just take this. If you have aldehyde at para, add 6. All other, you just add 4. Then just ignore these ortho and meta position values, because look at them, they are very small, mostly 1 or less than 1. So just ignore ortho and meta values. Now look at this. When we have at alpha position 8.2, 8.9, 9.1. So just add 9 here. For aldehyde or ketone, add 9. For carboxylic acid or ester, add 2. Acid or ester, add 2. Nitrile is an exception. Nitrile we will subtract 16. Nitrile we will subtract 16. So just go for this shortcut, right? When we have aldehyde or ketone, add 9. When we have a carboxylic acid or ester, add 2. Nitrile, it is 16. Ortho and para, when they are present at ortho and meta, we will ignore them. When they are present at para, we will add 4. We will add 4. Now we will look at the nitrogen substituents. Amine, NN dimethylamine, or an amide if nitrogen is part of an amide and nitro group. For amine, the values are 18.2 for alpha, minus 13.4 for ortho, 0.8 for meta, and minus 10.0 for para. For anion dimethylamine, it is 16, minus 15.7, 0.8, minus 10.5. If nitrogen is part of an amide, it is 9.7, minus 8.1, 0.2, minus 4.4. For nitro, it is 19.6, minus 4.9, 0.96. Now look at the shortcut. Except amide nitrogen, all others are 18, 16, 19. You can go for 20. You can go for 20. For amines, it is minus 10 when at para position. If amine is at para position, we need to subtract minus 10. If it is amide, we will subtract only 5. If it is nitro, we will add 6. If it is nitro, we will add 6. Now this is the case where we need to consider ortho position values also. The first one we need to consider only alpha. Next one we are considering para, and this one we are also considering alpha, para, and ortho. Just look at this, minus 13.4, minus 15.7. So just go for 15. If you have amine, what we will do? We will add 20 for alpha, minus 15 for ortho, meta we will ignore, then para minus 10, So 20, minus 15, and minus 10. For amide, take 10, plus 10 or minus 10, minus 5. Similarly for nitro, 20, minus 5, plus 6. Now we will have oxygen substituents, OH, OR, or O acetate. OH and OR, they are 28.8, minus 12.7, 1.6, minus 7.3. 33.5, minus 14.4, 1, minus 7.7. For O acetate, it is 22.4, minus 7.1, minus 0.4, minus 3.2. The shortcut is that remember only these two. OH or OCH, it is 30, minus 13. It is 30, minus 13. 30, minus 13. Just ignore the meta. It is minus 7. 30, 13, minus 13, minus 7. For OCH3, yeah, we decrease it by 10. So decrease it by 10, then go for by 2. By 2 here. So we will get 7, minus 7 or minus 3. Okay. So you remember for OH and OR, it is 30, minus 13, minus 7. Ignore the meta. Then for O acetate, 20, then by 2, 15 by 2 minus 7, 7 by 2 minus 3. And finally we have halogens, fluorine, chlorine, bromine, iodine. For fluorine, 33.6, minus 13.0, 1.6, minus 4.5. For chlorine, 5.3, 0.4, 1.4, minus 1.9. For bromine, minus 5.4, 3.4, 2.2, minus 1.0. For iodine, minus 31.2, 8.9, 1.6, minus 1.1. Here you just remember the values of fluorine and iodine. Fluorine and iodine. Both are minus 30. Yeah, at para we can ignore. For fluorine it is minus 4.5, but for others we can ignore. Others we can ignore. Then for fluorine it is minus 10. For iodine it is plus 10. Meta also we can ignore, right? So for fluorine and iodine, 30 minus 10 minus 5, or you can ignore it. For iodine, minus 31 point. Iodine minus 30 plus 10. For fluorine, plus 30 minus 13, so minus 10. Whereas for iodine, minus 30 plus 10. For chlorine and bromine, they are like carboxylic acid and ester. Their values are very, very low. What I suggest, just add 5 or subtract 5. For chlorine, add 5, bromine, subtract 5. You can ignore all other values. We will work out some problems so that we will get in touch with the shortcuts. This is mesitylene. Mesitylene, and it gives because this is a symmetrical molecule. It is a symmetrical molecule. So it gives only 3 signals. In the carbon 13, it gives only 3 signals because it is a symmetrical molecule. It gives one signal for this, one signal for this, and one signal for the methyl group. So it is a symmetrical molecule. Now we will try to calculate. For example, take this as C1, C2, and C3. Of course, methyl will appear between 20 to 50. So we are not worried about that. But we are worried about the aromatic carbon chemical shift values. So in this case, if we give numbering, it is 1, 2, 3, 4, 5, 6. So in this case, we will get same values for 1, 3, 5. Similarly, we will get same chemical shift values for carbon numbers 2, 4, and 6. Right. We will try to calculate them. Now the base value is 128.5 plus, as I said, when we have methyl group, it is 9.3 if it is at alpha position, and although we don't have anything, so we will, as I said, we will ignore it. We will ignore it. But we have meta methyl group. Meta we need to subtract minus 0.1. So we will also ignore it. When we do this, we will get around 137.6 ppm. But we will try calculating using my shortcut. As I said, for methyl group, if it is at alpha position, add 10, ignore the other positions. Ignore the other positions. So the resultant is 138.5. So it is almost similar value. Now we will calculate the C2 value. For C2, it is 128.5 because it is a methyl group at ortho, meta, para positions. Just ignore it. Just ignore it. Now when we do that, this is 128 point. The exact value is 127.1 ppm. Exact value is 127.1 ppm. But when we use the shortcut, we are almost there. We are almost there. So try utilizing the shortcut. Don't go for remembering exact values. We will try one more problem. Anisaldehyde. Anisaldehyde. it is not a symmetrical molecule, so it will give 1, 2, 3, 4, 5, 6, 7, 7 signals. Because it is not a symmetrical molecule, it will give all the 7 signals for carbon 13 NMR. Now to calculate the aromatic carbons 1, 2, 3, 4, 5, 6. I will number them like this. Okay. Of course, aldehyde it will be appearing at around 220. So 210 something like that. We are not worried about that. Okay. We are worried about these things. Now, if we want to calculate C1, C1, the base value is 128.5 and we have an aldehyde group. Aldehyde group, it is in the alpha and para. We need to remember alpha and para. Ortho and meta we will ignore. So alpha we will add 10, para we will add 6. Alpha we will add 10, para we will add 6. But meta and ortho we will just ignore. Sorry for this. We don't need, right? So for ortho it is we need to add 10. And OH is there at ortho position. When we have OH or OR, we need to consider ortho also. We need to consider ortho also. I said 30 minus 13 minus 7. 30 minus 13 minus 7. So OH is there at ortho position. So we will subtract minus 13. So the resultant is 131, right? Sorry, 125.5. The exact value is 121. Exact value is 121. Exact value, but with shortcut we are arriving at 125.5. Now we will try to calculate for C2. The base value is 128.5. We have OH at C2, so we will add 30. Although this side is not aldehyde. Aldehyde, yes. As I said, we will only consider the aldehyde at alpha and para. If it is at ortho or meta, we will ignore it. So we will ignore it because it is at ortho position. So the resultant is 158.5 and the exact value is 161.4. 161.4. Now we will calculate it for C3. C3 128.5 base value, and we don't have any substitution here. We have OH at ortho. As I said, subtract minus 13 because it is 30 minus 13. We will ignore meta, para minus 7. And we have for C3 we have aldehyde at meta position. We will ignore it. Aldehyde we will only consider alpha and para. For third carbon it is at meta position, we will ignore it. So the resultant is 115.5. Exact value is 117.4. Now we will calculate it for C4. C4 base value 128.5. We don't have any substituent on this. Alpha also, ortho position also we don't have. Hydroxy. Hydroxy is at meta. As I said, just ignore the meta. Then aldehyde is at para position. When we have aldehyde at para position, add 4. Remember carbonyl. Carbonyl we will add 4. For aldehyde, if you remember 6, it is fine. If you don't remember, for carbonyls, all carbonyls, just add 4 for para position. So 132.5 and exact value is 136.6. Don't worry about these deviations. Okay, they are almost similar. So just don't worry about these deviations. Now we will calculate for C5. We don't have any substituent at ortho, or we don't have any substituent meta on one side. Other side we have aldehyde, but as I said, just ignore the meta. We have para OH. OH it is 30 minus 13 minus 7. So we will subtract minus 7. So resultant is 121.5 and exact value is 119.6. For C6 it is 128.5. We don't have any substituent at C6. Alpha, ortho, meta, para, we don't have this side. This side we have ortho. Aldehyde is an alpha and para we will consider. Ortho we don't consider, leave it. OH meta we will not consider, leave it. So the resultant is 128.5 and the exact value is 133.6. So that means with shortcut we are almost there. We are almost there. This is enough for us for the exam point of view. For paranitrophenol, it is a symmetrical molecule. So 2 and 6 carbons will give one signal, 3 and 4, 5 carbons will give one signal. So altogether we will get 4 signals. Now for C1, yeah, I should have given the numbering in this fashion. For C1, it is 128.5. OH at alpha position, so add 30. We don't have anything at all, ortho and meta. Para, we have nitro group. Nitro, we can add 6. So it is 154, 163. So exact value is 161.5. For C2, 128.5 plus we don't have anything at alpha. Alpha OH is there, so we will add minus 13. Nitro meta, so we will ignore it. Para we don't have. So the resultant is 115.5, exact value 115.9. For C3, we don't have anything at C3. Now we have NO2 at ortho. For NO2, ortho we will subtract minus 5 and OH at meta, ignore meta. So 123.5, exact value is 126.4. For C4, 128.5 plus for nitro, we will add 20 and OH is at para position, so subtract minus 7. So altogether we have 141.5, exact value is 141.7. So this is how we need to calculate the lambda delta values in a short manner.